A device advertised as Degoogled. No Google Play services. No Gmail. No Chrome. No Google account logged in anywhere on the operating system. You boot it up, connect it to Wi-Fi, and run a packet capture on your network. Within 60 seconds, you see DNS queries to connectivitycheck.gstatic.com, then traffic to mtalk.google.com, then lookups for clients3.google.com, and a handful of android.clients.google.com endpoints. The phone is talking to Google, repeatedly, consistently, despite having every piece of Google software stripped out. How and why? This is a question that appears constantly in privacy communities, and the answer is technically specific enough that generic explanations fail. Let me walk you through exactly what is happening, what the different connection categories are, and what a Degoogled setup actually achieves versus what it is widely imagined to achieve. Start with the foundational fact. Android is not a Google operating system in the way that iOS is an Apple operating system. Android is the Android Open Source Project, AOSP, which Google maintains and publishes under the Apache 2.0 license. On top of AOSP, Google layers a proprietary suite called Google Mobile Services, GMS, which includes the Play Store, Play Services Framework, Google Apps, and various system integrations. A Degoogled Android build, whether it is Lineage OS without gaps, Calyx OS, Graphene OS, or a custom fork, typically removes GMS or replaces it with an open source re-implementation like MicroG. But AOSP itself contains code, written by Google engineers and shipped as part of the base operating system that references Google servers. These references are not Google mobile services. They are built into the core Android platform. Stripping GMS does not strip them because they are not part of GMS. The most prominent example is the captive portal detection system. When your phone connects to a Wi-Fi network, it needs to know whether the network has internet access or whether you are behind a captive portal, the login page you see at airports and coffee shops. Android checks this by making an HTTP request to a known URL and verifying it receives the expected response. On stock AOSP, the default URL is connectivitycheck.gstatic.com. Generate power. The server is supposed to return a 204 no content response. If the phone gets that response, internet access is confirmed. If it gets an HTTP redirect instead, the phone knows a captive portal is intercepting traffic. This check happens whenever network state changes. It is fundamental to how Android determines connectivity. The fact that Google hosts the server is a design choice and a controversial one, because it means every Android device on Earth phones home to Google every time it joins a network, before any user has logged into any Google service. Degoogled ROMs often change this default. Graphene OS, for instance, lets you configure the captive portal check URL through settings. You can point it to the Graphene OS server, to a Kukets run server, to Cloudflare, or disable it entirely. Calyx OS ships with its own default. Lineage OS generally preserves the Google endpoint unless you reconfigure it. If you install a bare Lineage OS build without gaps and do nothing else, you will see connections to gstatic.com because that is the compiled-in default. Second category, DNS. Even if you change your captive portal check, the phone still needs to resolve domain names. The default DNS configuration on AOSP uses DHCP to get DNS servers from your network, but certain system-level services have hard-coded fallback DNS. The Chromium-based WebView component, which nearly every Android app uses to render web content, has its own resolution behavior. Android's DNS over TLS and DNS over HTTPS implementations may default to specific providers depending on the build. If the ROM you are running includes unmodified Chromium WebView, that component has internal connections to Google-operated services for safe browsing checks, for component updates, for certificate revocation, and more. Safe browsing deserves specific attention. Google Safe Browsing is a service that checks URLs against a database of known malicious sites. Browsers use it to warn users before loading phishing or malware pages. The service is operated by Google. Chromium, including the Android WebView, fetches updates to the Safe Browsing database periodically. This results in connections to safebrowsing.google.com or related endpoints. On Graphene OS and Calyx OS, these connections can be disabled, but the default behavior, even without Google account login, includes them. Third category, time synchronization. Android devices need accurate time. The default network time protocol server used by AOSP is time.android.com, which resolves to Google-operated infrastructure. Without a correct clock, TLS certificate validation fails, and the phone becomes nearly unusable. NTP happens automatically, periodically, over UDP port 123. Every time your Degoogled phone checks the time, it asks a Google server unless you have reconfigured the NTP endpoint. Graphene OS allows you to change this to a pool of independent NTP servers. Most Degoogled ROMs do not change the default. Fourth category, system updates and certificate revocation. AOSP's built-in mechanisms for checking system update availability and validating certificate status rely on infrastructure that, in the default configuration, includes Google endpoints. Even custom ROMs may use certificate authorities whose revocation infrastructure goes through Google-operated servers. WebPKI, the system of trusted certificates that underpins TLS, includes CAs whose OCSP responders and CRL distribution points are hosted on Google infrastructure for some certificates. Fifth category, application-level connections that users do not attribute to Google. When you install an app, even from F-Droid or another non-Google source, that app may include libraries that connect to Google services. Google Analytics, Google AdSense, Google Fonts CDN, Google reCAPTCHA, Firebase Cloud Messaging for push notifications. Many open-source apps include one or more of these, sometimes optionally, sometimes as a required dependency. If you open an app that loads a font from fonts.googleapis.com, you have just made a connection to Google, regardless of how thoroughly the operating system has been stripped. This last category is worth dwelling on because it reveals something structural about degoogling. The operating system is one layer. The applications are another. Stripping the operating system of Google dependencies does not strip the applications. And the modern application ecosystem, including parts of the open source ecosystem, depends heavily on Google-operated services for functions that are not obviously Google-related. Push notifications are a particularly clear example. On stock Android, push notifications go through Firebase Cloud Messaging, FCM, which is operated by Google. When an app needs to notify you, it sends the notification to FCM, which routes it to your device. Without FCM, apps need to maintain their own persistent connections to their backend servers, which drains battery. Some privacy-focused apps do this. Signal, for example, can use its own WebSocket connection instead of FCM. Mali, a Signal fork, makes this configurable. Most apps do not. If you have removed FCM from your phone, those apps either lose push notifications or, through MicroG, proxy push notifications through an open-source re-implementation that still connects to Google's FCM infrastructure, because the protocol endpoint is at Google. That last point is subtle and important. MicroG is an open-source re-implementation of Google Play services. It provides a compatibility layer so that apps requiring GMS APIs can run without actual Google code on the device. MicroG does not reinvent the backend services. It connects to Google's actual servers using open-source client code. If you install MicroG to get push notifications working on a Degoogled phone, your phone is now connecting to Google's FCM servers. You have swapped proprietary Google code for open-source code, but the network endpoint is the same. This is by design. MicroG's purpose is compatibility, not network isolation. Users who want to avoid Google connections entirely need to install only apps that do not depend on FCM and do not include Google libraries. This is a much smaller set of apps than most users realize. Let me be concrete about what different degoogling configurations actually achieve. A stock Android phone signed into a Google account talks to hundreds of Google endpoints constantly. Location history, search queries, app usage, ad identifiers, account sync, backup. Every Google service you use adds its own traffic. A stock Android phone with no Google account logged in still runs Play services in the background, which connects to Google servers for advertising ID, attribution, anti-abuse signals, and feature updates. Removing the account reduces, but does not eliminate, Google connections. An AOSP-based ROM without GMS and without microG, with no additional configuration, connects to Google for captive portal check, NTP, safe browsing in the web view, and some system services. Apps you install may connect to Google independently, depending on their dependencies. Graphene OS with default settings connects to Graphene OS operated servers for most system functions, and to user-chosen endpoints for captive portal, NTP, and other system checks. It does not include GMS or microG by default, though both can be installed in a sandboxed user profile. If you install the sandboxed Google Play, that profile will connect to Google, but the rest of the OS will not. Graphene OS is probably the most aggressive mainstream implementation of actual Google network isolation. Calyx OS ships with microG by default, which means constant connections to Google FCM and related services for compatibility. It is degoogled at the code level, but not at the network level. Lineage OS without gaps keeps AOSP defaults, meaning you get Google captive portal check and NTP unless you manually change them. Many apps will fail to function without GMS, which some users work around by installing microG, which then reconnects to Google. The realistic interpretation is that degoogling is a spectrum, not a binary. Where you sit on that spectrum depends on your ROM, your configuration, the apps you install, and the work you are willing to do to audit network traffic. Tools like NetGuard, AFIwall Plus, or the built-in firewall in Graphene OS can block outgoing connections to specific domains, which gives you direct control over whether any Google endpoint is reachable. Pi-hole or AdGuard Home at the network level can do the same for every device on your home network. The deeper observation here is about what privacy from an ecosystem actually requires. Google's infrastructure is embedded not just in its products, but in the web itself. Fonts, analytics, content delivery, DNS, NTP, captive portal checks, push notifications. A significant fraction of the open internet routes through Google servers because Google has positioned itself as infrastructure, not just as a product company. Degoogling your phone is a meaningful step. It reduces the amount of data Google receives from you by orders of magnitude. It does not, in any realistic configuration, reduce that data to zero. If your goal is to reduce Google's access to your behavior, degoogling your phone is effective. If your goal is to eliminate Google connections entirely, you need to go further than installing a custom ROM. You need to audit every app, monitor your network, reconfigure system defaults, and accept that some conveniences, like reliable push notifications, simply do not exist in that threat model without compromise. The phrase "degoogled phone" is marketing shorthand. The reality is a series of choices, each with trade-offs about what data flows where. Knowing what those choices are is the difference between believing you are invisible to Google and actually understanding what Google still sees. The first state is comfortable. The second is accurate.